Okay, so here we are. We're taking our first calc video. This is chapter P, section A. You should have this printed out already. But you see at the top, it says right here, really nice and simple, an equation is linear if it contains only variables whose exponents are 1. And then it says, which of the following equations are linear? Well, right here, I'm looking at the exponents, and x and y both have power of 1 because nothing's written, so I know that that one's linear. Right here, this one is, this one's obvious. We've got an exponent of 2, so that one's not linear. Okay, x equals -3. Well, the only variable is x, and the power is 1. And so, yeah, we'd have to say that's linear. And we'll actually see what x equals -3 is going to look like in just a second if you're not sure. Now, this last one's a tricky one. Y minus 2 equals 1 over x. And you might start to say, oh, well, y has the exponent of 1 and x has the exponent of 1, so that must be linear. But you might also know from trig that this parent graph actually looks like this. And that's not linear, that's a curve, and it has an asymptote, two asymptotes actually. So why is it, you might be asking, why is it both of these have exponents of 1, but that's not linear? And the reason is because 1 over x right here, x is in the denominator. What kind of exponent would have caused x to move down into the denominator? And if you remember, that's a negative exponent. So this is the same as y minus 2 equals x to the power of -1 is the same as 1 over x. So that one is not linear either. Okay. So pretty simple. If the exponents are 1, then the exponents of the variables are 1, then you have a linear equation. And so moving down, what does the slope tell us? Slope is the rate of change of the y variable with respect to the x variable. So if I have some line that goes through these two ordered pairs, okay, then we have a change in x and a change in y. So right here, you see from this point to this point, it looks like that's at 2. That went up 2 units. But over here, from here to there, that went right 4 units. Okay. And so when I look at this, this delta y right here is going to equal to 2. What delta y means is the change in y. And over here, delta x is the change in x, and so that's how far left to right we move. And so we went right 4, so change in x is 4. Again, delta x means change in x. And you see that right below with the slope. Slope is the change in y over the change in x. You've always heard of that as rise over run. Okay, rise over run. Change in y is rise, up and down. Change in x is run, left and right. Okay. And you see the formula y2 minus y1 over x2 minus x1. So next problem, calculate the slope between the 2 points. We've got 2 ordered pairs. We're just going to label x1 and y1, x2 and y2. And we're just going to use the formula right here. M equals y2 minus y1 over x2 minus x1. And so we just go and we plug the appropriate values in. So y2, we go right here, y2 is 5. So 5 minus y1 is -3 over x2 is -2 minus x1 is 9. And then we simplify right here, the 2 negatives those are going to become plus plus, and so 5 plus 3 is 8 over negative 2 minus 9 is negative 11. So there it is, calculated the slope, no problem. Now, earlier you remember I promised you were going to learn what x equals negative 3 looks like, and that's either a horizontal or a vertical line. And x equals negative 3 is a horizontal line through negative 3. You see you have the x-axis right here, so negative 3 on the x-axis is right there. And so it's a vertical line through that point. You see the ordered pair is negative 3 comma 0. Well, what you'll notice about x equals negative 3, the vertical line x equals negative 3, well, what if we looked at this ordered pair right up here? What ordered pair would that be? That looks like negative 3 comma 4. Okay. And if we looked at a different ordered pair down here, that looks like negative 3 comma negative 5. Well, what's true about all of these ordered pairs? Okay, and you'll notice the x value on all of them is negative 3, and that's going to be true for any ordered pair on that line. The x value will equal negative 3, x equals negative 3. Okay, so that's why it's a vertical line. So hopefully, obviously, y equals 4 is going to be a horizontal line through y equals 4. There's the y-axis. So we find 4 on the y-axis. And it's a horizontal line. Okay. And again, kind of a similar idea here. This ordered pair was 0, comma 4, and you see the y value is equal to 4. Well, any other point on this horizontal line, the y value is going to equal 4. If we go out here, that looks like negative 6, comma 4. And you see the y value is still equal to 4. Okay. Now, right here for the slope, remember it's change in y over change in x. Well, on a vertical line, the change in x was 0, right? It didn't go left or right at all. And so anything divided by 0 is undefined. So a vertical line has an undefined slope. And over here, a horizontal line, well, remember, when we're looking at slope, change in y right here, that's your rise. Well, a horizontal line is not rising at all. It's perfectly flat. So here, it's going to be 0 over something else. And 0 divided by some run is just going to equal to 0. So any horizontal line has a slope of 0. And any vertical line, the slope is undefined. Okay. So it's good. Moving on to the next page. All right, so we have point slope form. This is from algebra. Now, point slope form is actually derived from the slope formula. I'm just going to go to the very top of the page here and make a little bit of space. Remember, the formula for slope is y2 minus y1 over x2 minus x1. Okay, and the way I get point slope formula right here, y2 minus y1 equals m times x2 minus x1, is you multiply both sides of the equation by x2 minus x1. So I'm going to go ahead and do that. Times x2 minus x1 times x2 minus x1. Okay. And so you can see right here, these cancel out, and you end up with x2 minus x1 times m equals y2 minus y1. And there's your point slope formula. Look, y minus y1 equals m times x minus x1 right here. It's just written the other way around. Okay. So maybe more than you ever wanted to know, but that's kind of where it comes from. So looking at the examples, find the equation of a line that passes through the two given points. So I've got my ordered pairs. I'm just going to label x1 and y1, x2 and y2, and I need to find the slope. So m equals slope formula, y2 minus y1, 2 minus 4 over x2 minus x1, 5 minus negative 3. And we simplify, we get negative 2 over 8, and that reduces to negative 1/4. So that's my slope. Then I'm just going to write it in point slope form. You could use either ordered pair you want. It should be fine either way. We're going to have y minus 4 because I'm using y minus y1. Y minus 4 equals the slope, negative 1/4. And then x minus x1 is negative 3. X minus negative 3. Okay. If you wrote that as x plus 3, that would be great also. Probably even better. Okay. Again, I use this first order pair, negative 3 comma 4 for my x1 and y1. You could have used x2 and y2 if you wanted also, and that would be totally fine. If you had written y minus 2 equals negative 1/4 times x minus 5, either one of those would be great. You wrote the equation in a line that passed through the two given points, and you should be good. Again, two negatives there. You change that to positive. That would be good. So let's try the next one. You might see something about these two ordered pairs already that is giving something away to you about what the equation in a line is going to look like. But let's go for it anyways. We've got our x1 and y1. We've got our x2 and y2. Okay. And so m equals y2 minus y1. That's going to be 1 minus negative 6 over x2 minus x1, negative 2 minus negative 2 equals. And same story here. That's going to be plus 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 plus. And so 1 plus 6 is 7. Negative 2 plus 2 is 0. Well, 7 divided by 0, what was that? We just looked at it when we were talking about horizontal and vertical lines. Divide by 0? Can't do that. So this is an undefined slope, which means that it's a vertical line, and the equation of the line is just x equals negative 2. And you might ask, how did I know x is equal to negative 2? Well, I looked at the ordered pairs. And I see that both the x values are negative 2. So knowing that this is a straight line, because it says equation of the line right here, okay, knowing this is a straight line, this had to be x equals negative 2 because it's a vertical line. So hope that's good. We're going to keep going. We've got slope-intercept form is y equals mx plus b. It says m is the slope, b is the y-intercept. And so we use slope-intercept form for graphing in particular, and it tells us the slope in the actual equation as well. So you see the method, you solve for y. To graph it, you graph the y-intercept and use the slope to find another point. So we're just going to do that. 3x plus 2y equals 7. We're going to solve for y. So subtract 3x on both sides. We're going to get 2y equals negative 3x plus 7. Okay. And then still getting y by itself, so everything gets divided by 2. And y equals negative 3 over 2x plus 7 over 2. So there is slope-intercept form. I can see right away my slope is right there, negative 3 over 2. My y-intercept is right there, 7/2. And so I'm going to use that to graph. And you know how big 7 over 2 is? It's about 3.5. So I'll put 3.5. on the y-intercept. Remember, this is y, x. And then the slope is negative, which means we're going down 3 and over 2. So from here, I'm just going to go down 3. It's going to be 1, 2, 3 over 2. Point right there. If you wanted to make another point, you could. 1, 2, 3, and over 2. And you just connect the dots. We should have a line. Negative slope should be going down to the right. If this slope were positive, it should be going up to the right. All right, now that's not the only way to graph. We can use the x and y intercepts. And so to find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. So we're just going to take this equation and we're going to find the intercept. So x-intercept, we're going to say 2x minus 6 times 0 equals 16. And then we're going to solve. That's just 0, so 2x minus 0 equals 16. 2x equals 16. Divide by 2, divide by 2. X equals 8. And I plugged in y equals 0, so I've got an x and a y. The ordered pair is 8, 0. And I'll plot that point over here on the graph, 8, 0. Now, for the y-intercept, we just set x equals 0. So that's going to be 2 times 0 minus 6y equals 16. And so we end up with negative 6y equals 16. Excuse me. And we divide by negative 6. And so y equals, those both reduced by 2, negative 8 over 3. And again, we plugged in x equals 0. We found y, so we have the ordered pairs 0, comma, negative 8 thirds. Negative 8 thirds, about negative 2 and 2 thirds, not about, exactly negative 2 and 2 thirds. And so I'm going to go plot that. 0, negative 2 and 2 thirds, right about there. And we just have a line that goes to those 2 points. So I'll draw as straight a line as possible. And there's my graph. So hopefully that's good. I'll let that sit for just a second and then we'll finish up on the last page. Okay. Moving on. All right, parallel and perpendicular lines. Parallel lines have the same slope. So if I was just saying, okay, let's look at y equals x plus 2. That has a y-intercept of 2, and the slope is 1. So you go up 1 over 1, up 1 over 1, up 1 over 1. Or if you wanted, you could go down 1 over 1 to the left. And we draw this line. Now, if I look at y equals x minus 3, you can see here that they have the exact same slope. They both have a slope of 1, so these lines should be parallel. This one has a different y-intercept. Y-intercept is negative 3. So we'll start down here at negative 3. But again, slope is 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Or you could go down 1 over 1 to the left. And when you draw a line through those points, you'll notice there we have 2 parallel lines. Now, perpendicular lines have slopes that are negative reciprocals. Again, parallel lines have the same slope. Also, just a little symbol for parallel. You'll see 2 slashes. Okay, means parallel. Symbol for perpendicular is an upside down T. Means perpendicular, they intersect at a 90-degree angle. So let's look at y equals 1/2 x plus 2. And this has a y-intercept of 2, so I'll start there. The slope is 1/2. So from 2, I'm going to go up 1 over 2. And from there, I can go up 1 over 2 again. Or I could go down 1 over 2 to the left. And I have this line. Now, y equals negative 2x plus 4. So you notice the slopes are negative reciprocals. Negative means the sign is opposite, right? So you see one's positive, one's negative. Reciprocal meaning the fraction is flipped. So if you flip 1/2, you get 2, right? You flip 1/2, you get 2 over 1. And so there they are, perpendicular lines, negative 2x plus 4. We're going to start at 4. Slope is negative 2, so that means down 2 over 1, down 2 over 1, down 2 over 1. And you'll see these two lines look like they intersect at a 90-degree angle, which they should because the slopes are negative reciprocals, or sometimes you hear it say opposite reciprocals. It means the same thing. Okay, the sign is changed and the fraction is flipped. So, next problem. Find an equation for the line that is parallel to the given line and passes through the given point. When I see parallel to, I should automatically know from right up here, parallel means same slope. Well, an easy way to find the slope is to write the equation in slope-intercept form. So we're just going to solve for y. We can subtract 4. So we get 3x minus 2y equals negative 4. Same thing, subtract 3x. We're just moving all the terms over, getting y by itself. So negative 3x plus 4. And divide by negative 2. Remember, everything gets divided by negative 2. So y equals 3 over 2x minus 2. Now, it's parallel to this line, so that means it has the same slope as this line, which means m equals 3 over 2. And it passes through the given point, so we have our x1 and y1 here. So we're going to use point slope formula. Y minus y1 equals m times x minus x1. And we're going to go ahead and plug those values in. So y minus y1, that's going to be y minus negative 2 equals 3 over 2 times x minus 5. Okay. And the only thing I would recommend simplifying here, I think I mentioned it on the last page, is the two negatives. You could rewrite that as positive. Let's go ahead and do that. Y plus 2 equals 3 over 2 times x minus 5. It did not ask you to put it in slope-intercept form. If you leave it in point-slope form, this is completely fine. Okay. Now, similar process here. The only difference is I'm finding an equation for a line that is perpendicular to the given line. So when I see perpendicular, I should already be thinking negative reciprocal. So I need to find this slope and then figure out what the perpendicular slope will be. So same thing, we're just going to get y by itself. The only thing to do is to get rid of this 2/3. So I'm going to multiply by 3 over 2. Multiply here times 3 over 2. And so that's going to give me 3 over 2 times negative 3 over 5 times x minus 4 equals y. Because the 3's cross canceled and the 2's cross canceled. And so I got y by itself. That's good news. We'll simplify. 3 and negative 3 multiply. That's negative 9 over 10 times x minus 4 equals y. Distribute negative 9 over 10. We get negative 9 over 10x. Negative times negative is positive. 36 over 10 equals y. You might simplify that, but we're not even using it. The only reason we did this was to find the slope, negative 9 over 10. So here, m equals negative 9 over 10, but that's not the slope of the line that I'm trying to find. I'm trying to find the slope of the perpendicular line. So that's opposite reciprocal, the perpendicular slope. I flip the fraction, and change the sign. That's going to be positive 10 over 9. So I flip this, change the sign. So we've got our x1 and y1. I'm just going to plug those values in. Y minus y1 equals m, perpendicular slope, 10 over 9, times x minus negative 2. The two negatives are going to become plus 2. And there it is. All right, we are almost there. All right, we're going to find a point of intersection between two linear equations. And so I'm just going to draw two lines here. Let's say I have one right here. One right there. The point of intersection where the two lines cross, that point of intersection is 4, 2. And the follow-up question to that is, when will two linear equations never intersect? And we saw that as an example on the previous page. They don't intersect if the two lines are parallel. And then the next piece of that is, when will two linear equations intersect more than once? Now, it does specifically say they're linear, so straight lines. The only time you could have more than one point of intersection from two linear equations is if they are actually the exact same line. So that's when they are the same line. And quick just image up here. Let's draw x and y axis. And if I have some line right here, and then the other line, I'm going to draw over it in red, is right there. Those have an infinite amount of intersections. Any ordered pair on these lines is a point of intersection, and there's an infinite number of them. So that's the only time two linear equations can intersect more than once. Okay. So find the point or points where the two linear equations intersect. This is just solving with substitution or elimination. I would go ahead and use elimination here. It's set up for elimination because the variables are all lined up really nicely. I need these coefficients to be the same number, well, opposites, meaning one positive and one negative. Opposite means the sign has changed. So I am going to be the same number, like 2 and negative 2, or 3 and negative 3. Or in this case, 2 and 3 are both factors of 6. So I kind of think of it like trying to find a common denominator. If 2 and 3 were in a denominator, then the common denominator between the two of them is 6. So what do you multiply this by to get to 6? Well, we multiply it times 3. And what do we multiply this by to get to 6? We multiply times 2. And I can multiply by positive 3 and positive 2 because they're already different signs, one positive, one negative. So that's going to give me 6 here and negative 6 here, and we're going to be good. So we have 6x minus 15y equals 12. I just distributed the 3 there. 3 times 4 was 12. 3 times negative 5y is negative 15y. 3 times 2x is 6x. And then I'm going to do the same thing on the second equation. 2 times 5, 2 times 2y, and 2 times negative 3x. 2 times negative 3x is negative 6x. 2 times 2y is 4y. And 2 times 5 is 10. And now you can see we got what we want, 6x and negative 6x, because when we add those together, they cancel out. And then negative 15y and 4y is negative 11y. And 12 and 10 is 22. Just bring that up here. Negative 11y equals 22. Just solve for y. Divide by negative 11, divide by negative 11. Y equals negative 2. And then let's see here. I found y, so I'm going to substitute that back into whichever equation I like to find x. You choose the top or the bottom, it doesn't matter, whichever one you like or whichever one looks easier. These look about the same, so we'll just plug into the top equation. We've got 2x minus 5y equals 4. I'm going to plug y equals negative 2 in for y right there. 2x minus 5 times negative 2 equals 4. So 2x plus 10 equals 4. Subtract 10. 2x equals negative 6. Divide by 2, divide by 2. We get x equals negative 3. When you are solving a system of equations, your answer should always be in the form of an ordered pair. That's going to be negative 3 comma negative 2. Negative 3, negative 2. And there we have it. Now, same idea here, we just have to write our equations. Okay? It says you and your friend Vanilla are selling shaved ice to earn money over the summer. You discover when the high temperature is 95 degrees, use 11 pounds of ice. And when the high temperature is 102 degrees, use 15 pounds of ice. What are the variables in this problem? Well, the variables are temperature and pounds of ice. The question is, which one is x and which one is y? Okay. X is independent, meaning x does not rely on the other piece of information. Okay, y is the dependent variable. Y relies on x. So how much ice we use is reliant on the temperature. The temperature is not relying on how much ice we use. If we use 15 pounds of ice, that doesn't mean that the temperature, that doesn't dictate what the temperature will be. The temperature dictates how many pounds of ice we're going to use. So x is equal to the temperature, and y is equal to pounds of ice. And so with that, we have two ordered pairs. We have 95, 11, and we have 102, 15. Okay. Now it says, assuming there's a linear relationship, you can't always assume that, but it's telling us in this situation, assuming it's linear, write an equation that expresses the relationship between the variables. Well, we've been doing that all along. We've got two ordered pairs here. So we've got our x1 and y1 and our x2 and y2. So we're just going to find the slope. M equals y2 minus y1, 15 minus 11 over x2 minus x1, 102 minus 95. 15 minus 11 is 4, 102 minus 95 is 7. And then we're going to plug it into point slope form, which if you remember was y minus y1 equals m times x minus x1. And so we just plug those in. Y minus 11 equals 4 over 7 times x minus 95. And so there it is, we wrote an equation that expresses that relationship between the variables. The last piece, use the equation from part B to determine how much ice you should buy. How much ice is y. So we're trying to figure out what the y value is. If the weather forecast is for a high of 90 degrees Fahrenheit, well, remember, degrees was x. So x equals 90. So I'm just going to take that and plug it into this equation right here. We've got y minus 11 equals 4 over 7 times x minus 95. And we're going to plug 90 in for x. So y minus 11 equals 4 over 7 times 90 minus 95. Okay. And so y minus 11 equals 4 over 7 times negative 5. 5 times 4 is 20, so I'm just going to bring this where I have a little more space over here. It's going to be y minus 11 equals negative 20 over 7. Okay. And then we're going to add 11 to the other side. Now in order to add these, I'm going to need a common denominator. So 11 is 77, well, let's do this, 77 over 7, okay? So you can see, this is plus 11 right here. 77 divided by 7 is still plus 11, but the reason I wrote it like this was so that I'd have a common denominator. So I wrote 11 with a common denominator. I did 11 over 1, and then I multiplied the top and bottom by 7, so that I could get the denominator of 7 right there. And I got 77 over 7. So we have y equals negative 20 and 77 is 57 over 7. And this is in the context of a problem. Y is how much ice should I buy? That's in pounds of ice. Okay. And there we have it. That's Chapter P, Section A, a good review of your algebra skills. And this would correspond with Chapter P, Homework 1. So enjoy.